Hello students, we're going to continue with our discussion of chemical bonding and reactions. In the last few video lectures we've talked about different kinds of bonding, ionic bonding, covalent bonding, and we've talked about the importance of carbon and how it forms covalent bonds with itself and with other non-metals, leading to a wide variety of compounds, including polymers and including molecules that we find in our bodies, biomolecules. In this video lecture, we're going to continue to talk about polymers, those very long molecules made by joining atoms together, usually by covalent bonds. And we will see how they are important in our daily lives. Now, there are two general types of polymers. One we call homopolymers, and the other we call heteropolymers. Now, what we mean by this is that a homopolymer has the same unit linked together one after the other. That is, polymers are long molecules in which units are strung together like beads on a string. In a homopolymer, all of the beads are the same. Whereas in a heteropolymer, the components that are strung together are not necessarily the same. The simplest is a repeating pattern of AB, 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 or red, blue, two different types of units that are bonded together. So you can be either a homopolymer or a heteropolymer. Now, there are a number of natural polymers that we find in nature, including proteins, DNA, cellulose, natural rubber, but there are also a number of synthetic polymers, plastics, polyesters, a number of materials that we use in textiles and fabrics. This slide shows three fairly important polymers. One is polyethylene. The one on the top, the one you would recognize as your trash can liner bags. Polyethylene is a homopolymer made of this small molecule called ethene, which is shown to the left. If many of these ethene molecules are strung together to form polyethylene, or what can be called polythene or polyethylene, it becomes a long polymer. And that leads to a polymer from which we can make materials such as trash can liners. A second homopolymer that you are probably very familiar with is polystyrene, or what we would call styrofoam. Polystyrene is made of a small unit, styrene, that is linked together one after the other to form polystyrene, a polymer of styrene, polystyrene. And one of the uses of polystyrene, of course, is to make styrofoam cups. Another very important polymer is nylon. Nylon is a heteropolymer made of two units. And at the bottom of the slide, you see these two units. The one on the left is called adipic acid, and the one on the right is hexane diamine. These two, you don't need to worry about what they're called. But these two units are different. If we think of one as A and one as B, they're linked together A to B, AB, AB, AB in repeating sequence to form what is called nylon 66. Of course, nylon, we make parachutes, we nylon stockings, a number of uses of this synthetic polymer. These are just a few of the polymers that you're probably familiar with. Many of you may have in your backpack or are carrying with you another very common polymer, polyethylene terephthalate, what is abbreviated as PET, because it's pretty hard to say, polyethylene terephthalate. But PET is what we use to make plastic soda bottles. You're also very familiar with both low density and high density polyethylene, such as the trash can liner bags, and probably polyvinyl chlorine, PVC. And you're very likely familiar with something called Teflon, which is another polymer. A few other general properties of polymers to tell you about. They can be either linear, that is very long molecules, or they can be branched, where there are crosslinks between different strands, giving rise to different properties. They can be either what is called thermosetting or thermoplastic. Thermoplastic means as you heat it up, it gets softer, it melts. Thermosetting would mean if you heat it up, it rigidifies. And also, polymers differ in whether or not they are biodegradable. That is, they can be degraded in nature or not. You know that whether or not a polymer is degradable or can be recycled is very important. And if you have a plastic container with you, you may look to see if you can see one of these triangles that is usually at the bottom of the container, and it'll have a number. Usually it's 1, 2, 3, 4, 5, or 6. And what these numbers indicate is the type of polymer, which then is used to identify whether or not it can be recycled and how it should be recycled, or if it's degradable. So these are some of the issues related to polymers, very important class of molecules. We'll pause now, take another brief quiz, and then in the next slide, we'll move on to talk about the phases of matter. See you in a while.